So as we know, when we're solving an equation, we have three possible outcomes. So far in this unit up to this point, we've only been dealing with outcome number one, which is one solution. I know that I have one solution when I see a letter equaling a number. All right, if I get x equals 1/2, letter equals number, that's one solution. The only possible answer for x in this case would be 1/2. That's what x equals 1/2 tells me. How do I know that I have infinitely many solutions? Does anyone remember what that result might look like? Yeah, Ben?
12 plus 12.
Exactly. 12 equals 12. If I end up with a number equaling itself, I know that I have infinitely many solutions. What that means is I can plug any number in for the variable, and I'm going to get a true statement when I work it all out. Does 12 equal 12?
Yes.
Yeah, that's a true statement. So if I work through everything and I have the same on both sides, I know that that's true. Infinitely many solutions. What might no solution look like? Levi?
5 equals 12.
5 equals 12. If I find out, after I go through all my solving, that I get a number equaling a different number, is 5 equal to 12? No. So if I end up with a false statement, I know that I have no solution. So like I said, everything we've done up to this point in this class have been one solution. We already know what that looks like, so we're not going to take an example. But let's look at what happens when I have infinitely many solutions. Let's say I have -2 times the quantity of 1 plus 4n equals -2 minus 8n. You guys see that in the back okay? Okay. So, what's the first thing I need to do in this equation here? What's my first step going to be? Combine like terms?
No.
No, what's it going to be? We're going to distribute. What am I distributing? -2. I'm distributing it to the 1 and to the 4n. Right? -2 times 1 gives me -2. And -2 times 4n gives me -8n. So right away, once I distribute that, what do I notice about my equation? It's got the same on both sides, right? Now, really, this is the point when we know my answer is infinitely many solutions, right? But if I were to add 8n to both sides, what happens to all my 8n's? They all disappear, leaving me with -2 equals -2. Now, that's more like what we wrote above in terms of, how do I know I have infinitely many solutions? Well, when I get this, is my answer -2?
Yeah.
Hmm?
Wait, no.
Is -2 my answer? No. Infinitely many solutions is my answer. -2 is one of my solutions, but I have an infinite number of them. What that means, again, is that any number I plug in for n is going to give me a true statement. 10 equals 10, 5 equals 5, 1,000 equals 1,000. Whatever I plug in, it's going to work for me. Okay? Infinitely many solutions. What if I have something like this? Negative 8x plus 7 plus 10x equals 4 times the quantity 1 plus x minus 2x. Am I going too fast? Yes? All right. That's all you got to say. Slow down. Bless you. I didn't realize so many of you use different colored pens. That warms my heart. What? That explains why I'm going so fast, because we got to swap pens in and out. Your notes all look great, though.
Thank you very much.
You're welcome. Last year I told my students, oh, get some Flair pens. One person maybe got them. Their notes looked great. Everyone else's looked okay. I'm just kidding. Your mom said no. I'm sorry. That's all right. You don't need them, but they help to me. Yeah, these guys right here. Are they erasable? No. Papermate Flair pens. Everybody up to date now? All right. What's the first thing I want to do here? Now, there's multiple answers to this question, but what's one thing I can start off with? Oscar, what can I do first? Distribute the 4. I'm going to distribute it to the 1. I'm going to distribute it to the x. Am I going to distribute it to the negative 2x?
No.
No. All right. 4 times 1 is 4. 4 times x is 4x. And then that negative 2x stays right there. What can I do on the left-hand side at the same time? Combine like terms. What are my like terms that I can combine?
4x minus 2.
Ooh, I'm talking about the left side.
Negative 8 and 10.
Negative 8x plus 10x gives me 2x plus 7. What can I combine on the right-hand side now? 4x minus 2x, which gives me 2x. All right. What can I do from here? What would my natural next step be? To get rid of the 7? Not the 7. We want to bring that variable term over to the left, right? What's the opposite of plus 2x? Minus 2x. But what happens to all my 2x's? They all go away, leaving me with 7 equals 4. I'm going to go down. Does 7 equal 4?
No.
No. So what's my answer? No solution. So this equation is broken. There's not a single number that I can plug in for x that's going to work itself out to give me a true statement. All right? There's nothing I can plug in that's going to work out. How are we feeling about this? Thumbs up, sideways, down? Kind of sideways? Okay. Here's a way that I like to explain this that hopefully will make a little bit of sense if your thumb is sideways, okay? I'll come back to this in a second, don't worry. these are my three options, right? If I have my classroom key, right, this big guy right here, right? What door does this key open? It opens my classroom key. Is it going to open Mr. Dutra's classroom?
No.
Is it going to open Miss Karan's classroom? No. This key only opens this classroom. That's one solution. You guys following me? Okay. Mr. Michaud has a special key. Anyone know what that key is called?
Master key.
A master key or a skeleton key. What door on campus does his key open? Every single door. Have you ever seen Mr. Michaud with a key ring with like 100 different keys on it? No, he only needs the one key because it opens every single door. Do you have a question about that? I don't know. I'm not a key engineer, but I assume it has something to do with keys. I don't know. But his key, you guys know, opens up every single door. If he wanted to walk in right now, he could just put his key in and open my door. He could open Miss Karan's door. He could open Dr. Freethy's office door. That one key works for every door here. That's infinitely many solutions. You guys get me? Okay. Now, what if I pulled out my car key or my house key? What door on campus would that open? None of them. Has nothing to do with campus. My house key or my car key. That's no solution, right? So my car key doesn't open any door. No solution. Mr. Michaud's key opens every door. Infinitely many solutions. My classroom key only opens my classroom door. That's one solution. Give me a thumbs up if you're following that logic there. Good. So those are the different scenarios. There are only three: infinite, no solution, or the most common, which is just one solution. All right? So when we get worksheet 5, we're going to go through and we're going to solve these out. Okay? We're going to solve them as much as we can. If we get to a point where we see a number equaling itself, that's infinitely many. A number equaling a different number, that's no solution.